pretty slow, actually. I could have done that myself faster already. 1 minute. I think codex typing with one finger. Looks a little bit different what I wanted or had expected. Wave 4 declaration. See his point. Why so difficult? Yeah, what a nonsense. I mean, that it works, but seriously, I don't get it. Why so difficult? There's no voice. I see a voice. Yeah. Here's my voice. Microphone connected to OBS. And, yeah, I don't know. Anyone does hear a voice? Okay, it compiles. Shall I run it? There's nothing to run, I'm afraid. I mean, it's still just this. Centered. Translate now takes a plot P2. That makes sense because this is in, well, centered coordinates, which is 2. This is transforming from P2 frame to centered. Yeah, well, why not? The very least, yeah, we probably have to construct that first. I think for drawing we want something that ends in pixels. But I don't know, maybe not. So this transform is a matrix, and this one converts from the P2 frame to the centered coordinate system. And then that means that it uses translate plot P2, which is in centered coordinates. So basically the vector that points from the origin of centered to the origin of P2. Translate. It wasn't changed. I have to look at the diff, I think. Math. Diff. Okay, it only changed translation vector. That's good. Which means that the transform is still the same, and we had transform was so that was taking a 2CS, which is the centered coordinate system. I'm going to say if it works, then it is correct. You could imagine that it had to be the other way around, but I mean a negated vector. Thus, Oh right, yeah, it makes the P2 frame centered, and then in the end we do make a P2 frame pixels by multiplying that with centered transform pixels, which you already had. So here we construct a more public, this is just a super temporary thing, a less temporary P2 frame coordinate system. Alright, that's just a transform. We need a coordinate system. For example, we already have a coordinate system. The centered one, called centered coordinate system. And that is constructed from centered again, transform pixels with the window geometry. And here we have the P2, and then it's from called P2 coordinate system, and we go from P2 to centered. Sorry, from P2 to pixels. That's okay. P2 frame transform pixels, yeah. I don't know, with the make in front of it. And the geometry is still window geometry. It's not super clear, I must say. Thus, yeah, that seems to be the correct coordinate system. I definitely want to show it. How can I show it? Let's first look at the div bounding box. So we declare a new coordinate system ID. This is my doing, I just renamed that. And then this block is new, which simply creates a new P2 frame coordinate system. And it has to be updated. Yeah, no, I don't think that makes sense. I think this construction just should go here. I think this one is new. Added that on coordinate system, so that would be div in math. No, it's not the case. Huh? You can do that afterwards. Okay. Just change the transform. Yeah, well, okay. Follows P2 and D2. Is that true? Well, yeah, P2 and D2 define the whole frame, so that should be true. And that works because D2 is captured by reference, and plot P2 is captured by reference, and this should be const. Is it const? It is not const. Let's make it const. See, it still compares. Well, you can't call add point on that. Yeah. If it is not const, then it could change. It doesn't change, but it could change. Maybe we should, the coordinate system is basically... I don't know, it's too complex. So let's say that I'm not convinced that it doesn't change. That probably is okay, but yeah, it's not const, so it could change. This is the transform. I was doing it wrong, I think. Looking for the wrong thing. And that one is const. No, okay, then it's okay. So this thing doesn't change, so it also doesn't have to need to be captured really. But yeah, well, okay, by reference, by const reference basically even, but I guess it will be a const reference because the thing is const. The most important thing is now we can only use this at the moment that D2 and P2 are already updated, and this one, so we don't, but it's not updated, so we don't need to wait for that. So that thing is being used here at the very top. I'm pretty sure that it's too early, because P2 is updated here, for example. And where's D2 updated? D2 is updated as a result of dragging Q2, I think. So it's not updated again here. D2 is used here. P2 is used here. I think just moving it down below this point is correct. Now P2 is updated. Okay. Yeah, I think I want to see it next. So how can I show a coordinate system? I have absolutely no clue. I have a limited memory. But I am sure I did. So, well, for example, I might as well just save this, I think. In I did this here, for example. This shows two coordinate systems here, the red and the green one. Oh, there's already display. And then add point can be done immediately after constructing it. Perhaps even not here, just keep it displayed. If we do it here, P2 frame coordinate system, display, layer, line style. Okay, make that red, line width. Okay. Let's see if now it is being shown. Draw lines. What's my namespace? Draw. I have draw. What was the problem here? Need draw. Okay, I'm just gonna call it draw line. Draw line space. Draw line style. I mean. Draw line style. Color is probably also not known. Color sits in Cairo window itself. Oh, you already have color. Okay. Compile. Box test. Well, that seems to have worked. We get coordinate system now, which is not updated. Okay. Totally not. No, it's just display apparently, and it's a one-time thing. The other thing is also changing. How did that work then? So here, all coordinates. This is inside the loop. Oh yeah, this is inside the loop. So just construct it from start. Construct it from start and then display it. I'm just gonna look inside display. Yeah, this is very dubious. So doing mostly M-place backs. Basically, it's just always using M-place backs, it seems. Totally doing that. Don't have a clear. I'll have to destruct this whole object in order to redraw it, I'm afraid. Yep, so now it moves along. Suppose that means that we no longer have to draw the lines that are now hidden also. Line 0 and line 1. So we have line 0 somewhere. stored in lines, plot lines. So we still use them, but you don't have to plot them. So just remove the plot. I think I already have another one that's called lines actually. Should get a collision. Or not? What do you think? I probably better first look for that before I change too much. No, there's no other lines. No, no, just this comes lines. Well, should still look the same. Yeah, and then I was super unhappy with this slop by the AI. What the hell? The only advantage is that now it doesn't include the header, but nah. Get restore. Just gonna erase this. These are private, and then you can use them by calling this. But I also want to support having an CS vector. I might well store that here actually. CS. To the math vector, CS vector. Only takes CS. It's just it's two-dimensional. Which it was already anyway. This is in math, obviously, right? I mean, namespace math. With that then. Translation underscore. This won't work anymore. Yes. There's explicit. Should still work. Right, CS vector includes CS, alright, of course. Of course it should. It doesn't. Well, it includes line piece. Math CS line piece, which includes direction. Which includes point. Math point, CS point, which includes size. Math CS size, which includes CS.h. So yeah, it is totally included. Don't need that here then. Could not convert to int. I'm taking the wrong point here. This must be a CS point. What? No, wait, help. This is in math CS. How is it thinking that point is a math point? The point is not defined yet. Circular header dependency maybe. Maybe that's the reason why the AI didn't want to include it. I'm just surprised though. Translation vector is involved here. So the problem is that it doesn't know what CS point is, which is because we are already including that, but never define it, because already at line 3 it exits there. The problem being that the moment you need CS point to be defined, it includes, well, there should have been this one. It says from, no, it's size. Okay, whatever. So size includes translation vector. So then we don't need that here. Size includes translation vector. So the problem is that now CS point needs size, and size needs translation vector. That is super weird, of course. Well, this is where you want to cut it. Don't want to have that dependency here. It's a weird dependency. Then translation vector uses CS vector again. Sorry, I want to look here. This includes vector because it reps vector. That cannot be helped. And then vector needs line piece. That's also kind of weird. Totally weird. Why would that be the case? Line piece. Can I not just for declare that one? I'll call raw on it. Dependent type though. It might be for the declaration might just work. Let's try that. But it doesn't compile at all at the moment. But if I don't include this, then this circular header dependency might be resolved. Might as well try that. So let's not include that and instead for declared. Line piece. Wrong number of templates. One should be 2. Well, it should be 1. So I think that again you have the problem that it doesn't know what the CS line piece is. So there is another circular header dependency now. And the reason is that I don't see it. I put it in the wrong namespace, I think. No, this is in CS. Huh? This doesn't make much sense. Oh, because I'm using the wrong. It must be CS. Oh, it must not be editor at all. Yeah, Okay, back to the wrong number of template arguments. It doesn't know what point is, so this is again a circular header dependency. CS point is being included, but not defined yet, because on line 3 already we call the include size, which includes translation vector, which then fails to define that and tries to use it anyway, which is going wrong. And where do we cut this loop? Just diagram needs a layer. Yeah, it does. A layer needs rectangle. Well, I'm fine with that. Rectangle needs CS rectangle. Probably okay, but let's have a look. Oh, rectangle is defined as CS rectangle with coordinate system plot. Totally needs it then. CS rectangle needs point. I'm doubting everything. Point and size. It wraps point and size. Oh yeah, totally needs that. Totally needs that. And then it also needs size, so I don't really even care that point needs size, although it's dubious, because we're gonna need size anyway, because we need rectangle. This needs size because add a size. So we have a, but it's again it's dubious because this is dependent type. So doesn't really need to be defined right here. That's the only place. Let's go the same route as the rest. I'll put it here. Class size. Everything for declared. The math point must be included because that's a member. Oh, the arrow changed. Does it now not know what translation vector is in point? Interesting. We are constructing it. Don't need a header then, I'm afraid. Or do we? I never know. Maybe I just forward declared and then hope for the best. See how far we can get with forward declarations. Translation vector. That would be a CS translation vector in math. In math. Nah, whatever. Why is there math all over the place here? Because we are in CS. I'm afraid here that we use a CS point. Math CS point. If I don't clearly say that I want the one in math, but this does not exist in CS. Maybe it should have existed, but it doesn't. And on the other hand, you know, well, dubious to put it in math in the first place. I think it's there because it's very tightly related to transform, and transform is put in math for some reason. Okay, and let's forward declare that one in math then. Sockage. Not that, so namespace math. Template anyway. Class translation, what was it? Translation vector. Translate vector. Translation vector. trends. I'm just typing it all. String is not defined in point. ToString lives in drawer symbolics, yes. Utils bit set, vector index, has ToString. Oh, or not. What the hell is utils ToString defined? You would say ToString. Go to utils, go in on math, utils bitset. That is specific for bitset. Vector index, specific for vector index. Has ToString. Here it is defined, ToString. In namespace utils has ToString. So we need to include it then. Where's my example code? Example code here. So that needs to be included in the namespace. This namespace. And still it doesn't know where that is. And that is because it should not use details, I think, in front of it. Okay, now I'm really confused. Yeah, and it's not true. Sorry, it's not true. The whole has ToString is for a member function ToString. Where the hell is ToString defined then? Wow. I can't find it. Can't find it. ToString does not exist, does it? thought I've been using utils toString. I mean, it worked before, right? I mean, it was here and it compiled. I'm missing a header, but it's just not showing me that utils toString exists. Apparently, it does exist. It just didn't show up in ctags. It's really strange. Utils toString. It's just there. Why is it not showing up in my ctags? Probably because it's defined in a really strange way. Utils toString. Need to include that. And then use utils toString. Yeah. So maybe ctags doesn't understand auto return type. So it would be hard to believe. Yep, it's not there. No. I'm shocked. Ctags failure. What was I working on? Oh yeah, this compile error. Even though rectangle size has incomplete type. The point is no longer including size. Brilliant. The comment is now a little bit over the top. So here it's not trying to include the CS point. That means that it is just missing in this header. It's slightly strange though, because then why is direct vector is included though? Direction should be included as well then. It's included. Well, vector is including the CS itself. Do I need point 10? Oh, this is so confusing. Let's try and just, I mean, illogical. If this works, and I really don't get why. No, it seems to have worked. Everything compiles. core dump. Counterexample for when it compiles it works. And the only thing I did was change a few headers. Shocking. What is this? Why so slow? Cannot convert. Yeah, I thought it was not explicit, so maybe it shouldn't be. Where is it? In math. Translation vector. It is not explicit. Oh, that was for a point, so excusez-moi. Yeah, then I should not have deleted it. However, might as well add a point here now, because apparently I wanted to allow points to be implicitly converted. No, wait a minute, that's not necessary. But I do need for declared. And then here we need construct this thing from a point. Is that even possible? Next. Data, I suppose. It is allowed explicit. There's an explicit conversion from point to vector. I think this is pretty explicit. Compile. I think we can delete this as well then. Symmetry. It's not needed for point, it's not needed for size. TSN. No, no. I am interested in neural networks, but the only thing I worked on was a lobotomized single neuron, and then abandoned that at some point. Well, no, I didn't really abandon it. I just got distracted by the graphics that I needed as visual feedback while working on that. So that kind of begins to reaches its conclusion. So I want to go back to that. But that's not an LLM, man. I wouldn't even have my data to. I mean, for the maybe just an LM, but no. If I would live 10,000 years, I would have said yes. Yeah, it's interesting. Okay, are we still crashing? Probably. We're no longer crashing. It's weird. Well, yeah, that's pretty weird actually, but maybe I should have investigated it first. I think anyway that this div looks good, so what I did is remove includes, and well, this is more like not using a raw type but using the coordinate system type internally, therefore also not needing this header but including that header, and this header already includes that. However, I added a for declaration for size and point, and then we can also convert those two directly. That means that they don't have to automatically convert to translation vector anymore, which means they don't need to include the header, I think. I don't know. It says continue. Most notably, we can now construct the translation vector with the power constructor from CS vector. It was now the wrap type, but hey, also from size and points. And point itself no longer includes size and translation vector. We just forward declare both. And well, okay, so we could drop this automatic conversion to a math translation vector, because translation vector now can be constructed directly from this type. Size also could drop that. And the vector is no longer including line piece, but instead for declaring it, breaking some circular header dependencies that we had. It looks all very good. Git commit. Yeah, mostly translation vector, I guess. Fix translation vector. To be let's say CS aware. It wasn't before because there was no coordinate system stuff enough in math, but now there is. So now reps CS vector and accepts CS size, point and vector. from structural arguments. Okay, broke view circular header dependencies by using more forward declarations. Window geometry. Rename. Create a coordinate system with origin, etc. Actually created. No longer plot those lines. Work in progress on F2 preframe. Okay. think I missed something though. Because I got rid of translation vector here and there. Yeah, see, this is not necessary at all. Which means that this can be changed back to just CS. This one is even worse. It includes it instead of for declaring it, but also no longer needs it. Math transform.h. This does access it, so we do need a define, I think. Cannot for declare this. No. Well, sorry, that does not access it. It constructs it by returning something. Here we do access it. The translate itself takes a translation vector by design, and that needs the x and y value of that. So it totally must be included somewhere. Might as well be included at the top as that works, if that works. Yeah, that's a translate call. That returns the translation as a translation vector. In that case, I definitely want an accessor, I think, instead of this. Don't want this at all anymore then. Yeah, okay, let's just return this. I'm gonna call this as vector. Oh, we still need that. But kind of only internally. Transform is this. No, yeah, no, not really. So I do as vector here, I think. As vector.x. Sorry, you said, can I ask what AI plugin you use for your Vim config? I don't. I had a plugin for what is it? Copilot for a short time, and it's still in there, but I disabled it. This is Codex. It's nothing to do with Vim. The Codex sailing. And if I prefer it, a bit much to say. I don't prefer anything really. I'm just playing with it because I'm curious. It still produces bad code often. So I ask a question, you have to wait 5 minutes for a code, and then you work 1 to 2 hours to fix it. It compiles. What did I do? I totally forgot what I did. I was doing some grep, I think. This one, yeah. So I did agree with this one, and this one, and this one, this one, this one. And I guess that one. That's just the implementation of the first one. Second one. And then translation vector itself is allowed to mention itself a lot. So there's the top and the bottom line on left. Draw coordinates. Oh well, cool man. Yeah, it's C++ all the way. It's the best language, I'm convinced. It's a language for intelligent people. That anyone who just can't code in C++, maybe they shouldn't, if you get what I mean. Yeah, this is weird-ish because I think that I've been trying, I think, to hide the translation vector from the user. So if then it pops up in user code, then something is wrong. Or it's because I want to multiply it with a half here. Why would I first create a translation vector and then multiply it with a half? Can I not multiply? Okay, I think I had the problem with the fact that it is a negative number, so I didn't want to multiply a size, which is a width and a height, with minus a half. That just feels wrong. You get a negative width and a negative height. Well, what I really want is to just go in the in the other way, the opposite way. So converting it to a vector does make sense, and then multiply it, and then have that automatically convert. So instead of using a translation vector, I think I should just use a normal vector. So just convert the size to a vector. And then the question is that supported? Doubt that actually. Maybe it should be supported explicitly or something. Vector, so you know, I need CS vector. You can construct from a lot of things, but like if we construct from a line piece, then why not from a size? Yeah. I think I should do it because a size is basically also a vector, just, you know, with a different name. And yeah, if you just want to go to the more mathematical thing of it, then you convert it to a vector. So construct a vector from a size being the vector from what is the size to begin with? The size is just size, man. 2D size. Still type safe in terms of the coordinate system, at least. And then even explicit front of it. This shouldn't harm. Okay, then size known. Do we need to for declared? I think it needs to be for declared. So this now should compile. That is very explicit. And then the vector can be multiplied with -1/2, and then it's all okay. It's no longer a size. And we can pass a vector to translate directly now. So we got rid of the translation vector at that point. Rust, yeah, I don't know. Probably in terms of career. Last someone asked me about it. I can't remember where. I asked. They asked which languages should I absolutely learn. It was even in real life. There was a girl that was studying IT, I think. And she asked me, well, she didn't ask me, I gave that advice myself. Well, she had to learn a lot of languages on the university. And I just remarked that if, if she could choose which languages, then she should be, at the very least, making sure that she was learning Rust and Python. And I was purely career, focused. If you want a job at a random company and you say, I can do Rust and Python, then you are more likely to be hired. That's my feeling. Anyway, I'm not really into this business anyway, but yeah, that's my feeling. Companies want you to use Rust, but it's a hype. If in my eyes, it's a hype. It just someone spread a rumor that Rust causes no crashes in your code and no exploits are no longer possible. That's kind of bullshit. Well, okay. So now everyone needs to know Rust because the managers believe that it is, I don't know, a magical language. So yeah, if even I would suggest a teenager to learn Rust instead of C++ because I think about their future, then that also gives me the feeling that maybe C++ is going to die. Then, if everyone does that, all newcomers only learn Rust. That wouldn't be good for C++. But I know not enough of Rust to really be able to say that that it sucks. I only looked at it for a week or two, I think. Codex itself is written in Rust. So I wanted to change Codex here. Codex, for example, I have this where I get a full dump of what it is doing. While here you don't get anything. You just get this stuff. It's a super short summary of hey, I might be executing something on your computer. And then in reality, here I can follow what it is really doing. So I had to change the code to get this this feed, this dump. And then I used ChatGPT itself to change its own code. Well, I used Codex to change the code of Codex Sally. And in the beginning, I didn't know anything, so I just had to formulate it in terms of what I know, and then it would write Rust code for me. And after a week or so, I started to be able to code things myself. And after 2 weeks, I didn't even ask the AI anymore. But I can't say I liked it. Nah, not really, no. Okay, I could be wrong. It's just, a hunch that I get from reading here and there something, Reddit or something, or watch YouTubes. So if you say that a lot of companies still want rather C++ dev, then yay, I'm all for it. I'm happy to hear that. In terms of technical difference, I think that Rust is mostly a hype. And if it is anything like Java was at the time, that was also a hype. So my take on Java is internet came up, and then the websites came up, and it became very popular, and people wanted to interact with websites, and the big money was in websites that sold something. So then you got forms where you could, type in your credit card number and your name and your email. But obviously, that was not complicated enough, so they wanted to make it more and more complicated, the user interface. But everything had to run on the server because the websites themselves were static. And that was way too slow. I mean, imagine that you have to type a key, just a single key even, on a form before the forms were there. And then the key would be sent to the server, and the server would update the whole page to display your key. That doesn't work. That's why forms came up. And that's then with all the user interface. So the immediate feedback and animations of the user interface need to run on the user's computer. But then you could get malicious. I mean, if the website decide what code runs on the user side, on the client side, then you could have malicious servers where you go to and they say, hey, execute this code for me because it's a user interface. And then you would run it, and then, it would steal all your information or something, or wipe your disk. So something was needed that was absolutely secure to run in a browser, but as powerful as they could get it. So they wrote a completely new language, Java, exclusively to, with in mind that someone malicious would be writing it and would try to do something on the computer where it runs that you don't want it to do. And that absolutely included not having memory pointers. And so garbage collection, okay, but you can't do a malloc and then have people write to memory. This is way too dangerous. But the result was, of course, something that is terribly slower than C. Terribly slower, because it had all those safety things in it. But very useful to use for website user interfaces that run client side, yeah. And then some idiot started screaming, oh, what a good language. Oh, this is better than name any other language. And that you got something like Java coders who wrote any program in Java, not just the user interface, but any program. It is ridiculous. Absolutely ridiculous. So they worked their asses off to write compilers for it, so it wouldn't be as slow as it typically would be. But yeah, they never caught up, of course, with the real speed of lesser safe languages. And now they have Rust, which is, if you ask me, companies discovered that Java maybe was not the best, but they still wanted memory safety. All those exploits are mostly stack overflows and array overflows, underflows, stuff like that, memory related. So they thought, well, Java has something. It's just so slow, I can't run a whole company on Java, but I do want to have this memory safety. It's not a middle way. So not a language that is fast, but still makes it very hard to make memory errors, because most exploits are based on that. And then Rust, I think, already existed, but it became popular for that reason, because it is a lot faster and still has some of those securities. It's way more suitable for everyday programming than Java, which was never intended for that. However, I think it does come with a price, no matter how you put it. Still a lot of safety in it that yeah, reduces flexibility and maybe makes stuff a little bit slower. But the same holds for C++ now, if you ask me, because since Rust, and especially the popularity of it, the C++ the designers, say the committee or the compiler devs, maybe, I don't know, they were forced to add a lot of security in C++. Before I would just crash if I made an error with a standard vector. Now I get an error. It doesn't crash. Crashing means it is exploitable. Now I just get an assert that my index is out of range. So if I try to use operator square brackets with an index that's too larger than the size, it doesn't crash anymore. Which means that every access to my vector and to my array is being checked. That makes it slow. Yeah, that's their answer to, hey, but C++ is safer now. You might as well use that. Maybe you can turn it off at some point if you start to believe that, okay, my code is written correctly. I don't need those asserts. Maybe there's a define that you can do and then turn those things off. I don't know. They just started happening, so I think, oh, they made the standard library slower, or probably as an answer to Rust. Okay, by now I have no idea what I was doing anymore. Wait, actually, I did this. Yeah. Okay, so this is the last one. To look at it, if hopefully I can remove it even. Yeah, this is the same thing, right? This is user code that is using a translation vector. I didn't write it. It's absolutely written to by an AI. And then I accepted it, but it shouldn't. It shouldn't be accepted. Hell, it shouldn't be using X and Y. It is double. That is not coordinate system safe. So the whole tx, ty should be a vector, or yeah, probably a vector. Just keep it mathematical. And then we can just pass that directly. So what is it doing here? Yeah, this indeed is written by Codex by ChatGPT. So we want to solve this, but then as vectors. Well, in vectors, that would be yeah, this minus sign here is slightly annoying. So there seems to be a mirror involved. I don't have a mirror, I think. I do. I have an rotate 180 degrees. Let's see. Rotate it 180 degrees. Oh no, that's mine is both things. Chide. Yeah, I'm not supporting mirroring so far. Maybe I should add it. I'll have a rotate, might as well add the mirror. Kind of belongs in here now. Just swapping X and Y and adding minus signs. So you can swap x and y and add a minus sign for one before one of them, or the other way around, or not swapping and add two. And the identity would not swapping and add nothing. But then we also have the option to not swap and add a single or remove a single minus sign, which would be a mirror. That would give me, let's say 1, 2, 3, 6, so 3 more, but that would be a combination of rotation and mirroring. This may be a little bit too much. Let's just add one mirror and then do a mirror and then that. Compiler will optimize that anyway, hopefully. This is for direction though, so I was thinking vector. Let's see, it is direction also, vector. Also no mirroring. Mirror. Well. Yeah, reflect. What's a good function name for this actually? Flip. I like flip. It's a nice short. It's also, let's say, makes me think about flipping the chessboard. Not after I lose, but in the light chess. Swap black and white. Totally one axis that is being negated. Yeah. X reflection. This is a bit long, what I had. Reflect across x-axis. Not too long. Flex over x-axis, same problem. Flips, nice. Just reflects. Reflect y. Negate y would be. Yeah, I don't know. I'm gonna go flip. Negate y. Yeah. Yeah, okay. For For this reason, maybe I should use reflect then. Reflect or reflection. And this says rotated, so it's already be done. So we have it, and then we have it reflected. This is my mind again. X-axis is gonna belongs in there. So the best name is across. Don't really like that. Someone native English for that. Tell me if that's better. You do reflect in, no? Across. Yeah, and then of course, since the length is preserved, this also has to be part of direction. Nope. Only two of them? Sector ops, specialization. Then there's the other vector ops. Oh, those are the two then. Oh, okay. Yeah, I knew something was missing. Okay. T. Go again. Direction. Vector. That's it. So now we can write this as follows. X accent, now replacing, well, being a vector, X and Y accent is X minus range Oh boy, they have a different X and Y range. It ain't that easy then. Well, it's a non-uniform scaling that we need there. Which I can do apparently. But this is for transform. I don't have a non-uniform scaling for vector. Maybe we should add that too then. Or maybe I'm going too far, actually. Maybe we should just keep this. It's hard to code this because I'm not grasping what it is doing. This is about plots. And we are creating or initializing CS transform pixels, which is a matrix that converts CS to pixels, where CS is the plot coordinate system. Okay, let's make an ASCII art and drawing. So you have a window. Inside the window we have a geometry. And inside the geometry we have an x-axis that starts at some point. Damn it. And then we get the origin there. think the X min and max are actually on this line here. They have the full width of the geometry. Otherwise it wouldn't work out. Feels like I have to introduce a scale vector. Just like we have a translation vector. Yeah, can't make anything better with this. Looks good. I mean, still a plot. Let's see. Blah, 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 blah. What was I doing? This. I think translation vector is now completely hidden from the user. Yay. As it should be. There's some intermediate thing. Might as well keep the reflection, I suppose, although I'm not using it now. So that was this one. After fixing the AI slop. And I was working on add a new coordinate system object that represents this coordinate system, making sure it uses the correct translation and rotation. That's done, right? That is done. Bounding box test. Yeah, it's still the same thing, I guess. Okay, next I want to have these 4 points in a vector or an array in a certain order, namely I think just rotating clockwise or something. Could start with the point with the smallest x. No, we have them on this axis here. So it's simply the. Let's start here then. You start with positive x and then positive y and then negative x, negative y. So that direction. Let's prepare that. There can be an array. So I think, yeah. Source list vi bounding box test. Store intersection points counterclockwise in array. Standard array, and I'm using math CS point for it with coordinate system ID P2 frame. Yeah, 4 of them always. I only have the plot IPs, which are currently in the standard coordinate system. Do we have any knowledge how they are stored? Okay, I think that L equals 0 here is the x-axis. So the vector here stored is or rather the array here. The array index is which axis it is. And then the order in which this is stored is the order in which IPS is returning stuff, which is intersection points. What is the order? Determine the clockwise order in which the four corners of this two-face occur. Looks like it's for three-dimensional something for a cube. Why do I talk about it about a cube? Talk about it as if it is a cube here. Just for arbitrary dimensions, no. Can there two-face? Okay. Oh yeah, right. Yeah, okay, never mind. I mean, every hypercube has two faces in the end. We just run over all of that. Except, of course, when it doesn't have that, in which case this story is not important. Or it just comes down to having the rectangle itself being a single two-face, I think. Yeah. Is start then the first one? Guess so. Definitely not easy. I think there's some logic in it, but figuring it out by using code, probably better to label them and then see if we can figure out what the logic is. So PS push back. I guess this is where it is drawn. Yeah, here's the great point. So I want to have text as well. Need an example. Almost everything will do, I mean, but as gyro window tests, but which one shall we use? Which one has points with a label below it? This one. Next to it. I want to have it below it. Is that not possible? Well, this is possible, but surely I haven't. I have no idea what I do. I just can't remember that. Backtrack. This did not have something. So on the other side. The V is below it. I'm not sure that this thing is not animated. Maybe not the best thing to look at. Still not draggable. Oh, so something is draggable. Hardly down. Or which one is it? This is draggable. So yeah, the V changes and it is below it. So I have to look at the V here to steal my code. And that was quadratic Bézier. Great point. It's just centered below, so I could have changed that, of course. After creating a point, you can plot text like this below it. Here's the create point. This is then my adding my label. However, this uses plot, and instead of plot, we need centered coordinate system. Instead of the second layer, we need a layer. I need a label style. And V is my point. And this must be a string of L. Is it not two string or something? Is it not working? L. Hopefully that works. And then we have to push that back also to something. Plot label L. dot pushback I need an array with text. I don't know what goes here. Text, and this is plot label. Labels. Create text. Returns a text handle. Oh, okay. So always returns text handle. It's just plot text. The text handle is coordinate mapper stuff. We just use plot text. Make it fail. No way it is going to compile. Type value mismatch at argument 2 in template parameter list 4 template blah blah. Standard vector. The 2 ended up the wrong place. Vector something. Oh, just missing closing something. Same remark. No way it is going to compile. Oh yeah, I forgot to have add a line style. You need a line style. Where did I steal this from? From here? I think so. Line style. No, label style. Label style. It is by default centered left off, and then I override it. I might well change the default then. So label style. So you need let's put it below. That doesn't help. Well, it tells me which line it is. I already knew that. Well, L was not what you were looking for. No, we want to have an enumeration of the order here. So rather I need the size of the plot PS, IPS. So the order is, this one is first and then that one. And here it's the upside down, well, but the y-axis is down. So it's kind of the same thing. What happens if I rotate this? Okay, I think I see the pattern, yeah. The negative axis, the negative side has a 0. And the positive side of the axis has the 1. So it is the negative side has the 0. Exactly how we want it, right? And then the first one is x-axis or y-axis. I think I put 2 months into getting that right, that order, so we better use it. Yeah, this is no longer needed then. That was a lot of work to create though. Just comment it out. So I want the positive x-axis first. And that thing is stored in here. And the x-axis was, I think I have a label actually somewhere. X-axis. What is that? Where is that defined? Or the coordinate system. And plot area and namespace plot. Simply plot. And then the positive thing of that, because that gives me the vector. And then the positive thing is 1. Or did I also have something for that? Because I saw something. Yeah, max range. Not really. Let's use 1 here. And that returns a plot CS point, but that is derived from this. So that should be okay, except it returns it in centered coordinates. So I have to multiply that with centered transform P2 frame. And then hope that it exists. I think it's the inverse, huh? We don't have this. Yeah, so the other way around, we do have the other way around. Now let's just create it, because I need it 4 times and stuff. So I need the one that already inverts it here. There is an inverse. Inverse, matrix inverse. Transform. This doesn't really do anything. It just changes type. Reinterpret cast where the type gets a different boolean as template parameter. But you want to actually calculate it, otherwise it's going to calculate it again in the loop itself. Inverted, but that is only called on the internal thing. Inverted, yeah. That was the last one. Yep, that compiles, then it works. No need to test. It's not compiling. It's not declared in this scope. What? This also does not exist. Of course it does exist, only for a short time. Apparently, the thing only exists while using this lambda, which we're using here, and then I guess it ends up in my coordinate system. Surely my coordinate system will reveal to me what that is. And where do we see the transform here? Coordinate mapper. Just go straight to coordinate. Oh, here it is. Transform pixel. No, it's using. Okay, so coordinate mapper has this thing here, and we want to access that. What? Pixels? Okay, so we only have pixels. Well, hopefully I was needing pixels. I think I was needing pixels, yeah? Yeah, I was needing pixels. I'm not needing pixels. Okay, well, we have to work with it. We have this. I think that's the only thing we have. No, we don't even have that. That was the thing that I had to call. I have a coordinate system. You have a centered coordinate system. Definitely this must be the one. There it is. I don't need that one though. I need this one. We have this transform here. Center transform pixels. That's one thing, and then the other one that we need is the P2 frame something, and that's going to be the coordinate system then. Coordinate something. This is what we have. And then on that one we can call CS transform pixels. So yeah, I have to divide that. Is that working? Probably not. Nope, dividing is not supported, I think. I have to multiply this with the inverse, therefore. So we multiply this with the inverse of this thing. Inverse or inverted, doesn't matter now. Okay, so it is correct. We have this, and then we call that, you get P2 frame 2 pixels, and then inverted is pixels 2 P frame. So center 2 pixels, and then from pixels to frame, and then you get center 2 frame. P2 frame, I mean. No need to operate on multiplication. Operand types are transform from centered to pixels and math from frame to pixels. Yeah, that doesn't work. This must be the other way around. That is very weird. Oh, wait a minute. The P2 coordinate system is actually from pixels to P2 frame. This is the 2. I think it's a 2. So I would just remove the inverted then. Yeah, it's the first time I needed the type safety. This does compile then. That's what we wanted, but no, it does also not compile. So what do you have here? Again, this should be from centered to pixels. Centered to pixels. And then we can multiply that with pixels to something. But the transform here is from P2 frame. Still, even though I removed the inverted. Is the inverted wrong then? Invert. It's invert wrong? Looks like it. I think invert is wrong, man. Or inverse. I had inverse here. Now let's try the other one. Inverted. I'm flabbergasted. That is wrong. It just returns transform. That is not correct, man. Inverse should work though. This does swap the 2 and the form. Yeah, it is from 2, and then there they are swapped to from. That should be correct. We'll have to fix both then. Let's then first fix the other one. Inverted should be almost the same thing then, but then let's see. Where is my inverted here? Inverted. So this is going to be, that is inverted, this is not changed. Backend stays the same. And this is now inverted. And now I need to return something that is reinterpret casted to that type. Can only do that if we first calculate a transform, of course. I just have to construct one. I have to construct one anyway, I think, because we really have to invert it. Yeah, so must construct one. So it's not a reinterpret cast. It's just well, whatever the return value is, constructed from the inverse. And then what would that call? This is then the same type as M. Still find backend, and we can construct from a find transform backend. Yeah, this should be okay. So now inverted should work, because I fixed the coordinate system order. That worked, right? Almost. And absolutely not. Oh boy. X-axis is not a member of plot. Well, I saw it in plot, so maybe just a missing error then. I meant this one. Plot, draw plot area. Okay, that is very far-fetched, just for those constants. Plus it is not really related to these indexes. How many? 4, I think. Nope. 3. I have to repeat that. You got to be kidding me. It's still the same error. Oh, no, it's required from here. Never mind. Warning, returning a reference to temporary. Oh, yeah, I just copied that, but this is no longer a reference, obviously. You have to actually construct it. Call it a typo, or rather a pasto. I think that worked. Clearly it worked. Are we going to wait here or not? This is pure waste of time. My life is passing by. Not in a good way. I'm just going to press Ctrl C here. Let's go here and then not go there. Let's go here. No, let's go here. And then if I do inverse, that should also work, but it doesn't. Have to fix that one as well. It's working. What happens? Did I just start World War III? No, it compiled. Okay, well. Bounding box test with the B. Oh, it is not drawing anything, is it? No, it's not drawing anything. Listening to the most horrible music ever. It's thumbs down. Thank you very much. Yeah, okay. I have the array now of the section points in the correct order. And then the difficult stuff starts. Very difficult stuff. I immediately feel like stopping. It's way too difficult. Let me think what I really want. There's just a lot of different ways. A lot of different ways. That is a bit too simple. I might well remove that. Nou ja. I did write something that prints stuff, and that stuff is not here, I think. Maybe this stuff is in Cairo window tests, although it seems very unlikely. No, not really. Trying to remember how I called it. In fact, I think I deleted it. It's not here. I deleted it. It was not here. I did talk about it with ChatGPT. There's a lot of stuff that I never named, just new chat. There is my program. Hey, Katarina. I have an interesting puzzle for you. If you can help me. I have this yeah, it's a bit difficult to describe, unfortunately, but so I'm having 4 points on an axis. So ignore the rectangle. It's just how to generate it. The rectangle is unknown actually. So we just have this axis coordinate system with 4 points on it, 1 point on each axis. I have those points stored in the order positive x-axis thing first, and then the positive y-axis, negative x-axis, and the negative y-axis. So counterclockwise, starting at the positive x-axis. And now the question is, find an algorithm that generates every rectangle, for example this one, that goes through these points. And of course, since this is a solution, everything where this side is further away is also a solution. So you have to generate the largest rectangle, which is then would be infinitely long, but then restricted to having an aspect ratio of a maximum of 2. So in this case, if we gamble that these 2 points belong to the top, and this one belongs to the bottom, and this one belongs to the left side, then we know the height, because we have both the bottom and the top. And then we know that the maximum length is twice that height. So we can just draw a rectangle that has a ratio of 2, something like this, a little bit longer than this, I think. But if, for example, the points that we have are this, that's slightly different. Now we have only, I mean, at the moment that we gamble that it is something like this or something like this, yeah. You can also draw a rectangle like so or something. I don't know, but if you consider the possibility where these 2 points are on the top and these 2 points are at the bottom, then you both you neither know this one nor that one. So that's a little bit harder to draw. However, you can give a bounding box. So if we know the height, you can shift it this side as far as possible to the right. So it is here. So this becomes the corner then. And then make it twice as long, and then you get the limit here. And you can shift it to the left so that this point here becomes that corner. And then make it twice as long as that, and then you get the other one. So then you get something with an aspect ratio that is larger than 2 even, simply because you have basically show the bounding box of the rectangle that would fit in there. So in that case I want that to be drawn. Now it is a given, I think, that for every possible situation do I have voice? Did someone remark that I did not have voice? I feel so stupid. I can't follow you. This is all I have. I don't have output yet. I need an algorithm. We know that these points are generated by a rectangle, so they are a little bit more special than arbitrary points. That's a good question, actually. No, of course not. It's not. They can be arbitrary. Just any point on the positive x-axis and any point on the negative x-axis, etc. It's a 4-dimensional problem, basically. They always have a rectangle that fits, namely a rectangle that is aligned with the axis, just like this. So if I rotate it like this. Now you have any points can be generated on the 4 axis. On the four values can be anything. These two can be low, and these two can be low, or these two can be low, or these two can be low, and then the others large, depending on the axle size. The only restriction here is then that the maximum aspect ratio of 2, which is also not really existing, by the way. just to get an output in certain cases. The structure of the input, oh, you mean, just hard code? Well, you're going to be disappointed, I'm afraid. This. I have an array with 4 points. And each point is 2 doubles, x and y coordinate. That's all I have. So, for example, in this case, you have a point. Let me quickly cheat. In this case, you have an array with points 400, 0, 0,250, minus 400, 0, and 0,200. So they're not really points because there is always a 0, and you know where the 0 is. So I could also give you an array with just the values 400, 250, minus 400, and minus 200. Minus 200. Although the absolute value of these two, of course, don't have to be the same. I could have this, say 500, 350, minus 200, minus 100. And the output has to give even the orientation of the found rectangle. No, the output is an algorithm. But you want to know what the output is of the algorithm? The final output should be a bounding box aligned to this axis. So a rectangle like this, aligned with the axis, that guaranteed encapsulates all those generated rectangles. But I want to draw the rectangles, so, to get a feel for it. Yeah. Well, the output is infinite of what I ask at first, because I asked for all possible rectangles that fulfill this. So give me give an algorithm that generates all rectangles which are an infinite number, of course. Well, of course, yeah, I think so. Well, yeah, because as a function of rotation. So if you want, you get a free variable, an axis rotation. Let's say, yeah, we have a rectangle that is wider than high, and then you get the center, and you pick one of the far sides as being the positive one, so this point here. And then you have a direction from the center here to that. So there's a direction here, and you can drag that around, so we can make it rotate. So now it is oriented like this. But if we would drag this, then this rectangle would rotate, yes? But while it rotates, it would continuously keep going through all these 4 points. And I think actually that maybe there might not be infinite number, because is it even possible to rotate it a little bit? If you rotate it a little bit, then it's no longer going through these 2 points, of course. So is that even possible? I think that might not always be possible to have every possible rotation. If there is a finite number of rotations, well, each rotation I think has only one rectangle. But no matter if there are infinite number of such rectangles that go through these points, or a finite number, because the final output would be a rectangle that is the smallest axis-aligned bounding box around all those generated rectangles. And that's finite, because each of the possible rectangles is finite. And it is finite because I put that limitation on it, that the aspect ratio is at most 2. I wish I could show you more, but I only have words. This is all I have. But I can tell you a little bit more about my thoughts about the algorithm. You see, you can generate many rectangles, but you can categorize them. For example, you can start with all rectangles where the 4 points that you have are each on a different edge. Not this, yeah, because these two are on the same edge. So this rectangle, no. But no, it's not possible. So under this rotation angle, this angle here, it's not possible to put all the points on a different edge, except when you make the rectangle smaller. Then it would be possible. So if you say generate all rectangles where the points are all on a different edge, then I think you get you still get an infinite number of rectangles for each orientation. And if I want this rectangle to be a solution, then I have to rotate it a little bit like this. Yes, you also want to be able to draw in it. The collab mode. Oh, that's a difficult question. I had an side, so I don't dare to click on anything. Oh, my privacy. I had a free drawing site somewhere that I liked. Maybe Sketchpad, because it is highlighted. Welcome to. Looks like. Nope. You can draw. I'm not sure that though it is collab stuff. Classroom setup. I know, man. The whiteboard, yeah, they have that, but what I like so much about the other one is that you can draw rectangles and straight lines and stuff like that. Collaborative painting. Do you have a site otherwise, if you can't find it? Understood, you have a minimal rectangle for every orientation. Given the 4 tuple of points. Not a bad take, actually, to first look at the minimum rectangle. But it's not interesting for the final question, because that would give possibly a smaller bounding box than what is what we want. But okay, it would be start if you want a minimum. Where the orientation is, I guess, is in 0 to pi divided by 2. Yeah. Unless you say that the orientation is towards the longest side. But I guess in the minimum case that is irrelevant. I guess it is. Okay, yeah. Then 0 to pi over 2 would work. Isn't that like suddenly very easy if you do that? Just make a big rectangle with a given orientation and then shift one thing back until it hits one of those points, or both. Yeah, that would be super easy actually. I mean, in terms of algorithm. Hell, that would be extremely easy. I can even code that in like 10 minutes, I think. Let me emulate this in my head. Yeah, Ben, it's so easy. Maybe the AI can do it. Think about how to communicate the direction of the that orientation. If I want to do it manually, could use a slider, but maybe just a second circle, and then have the orientation defined by the direction of a line through the center here again. Okay, let's do that. You have been silent for a while, Coterino. I'm just worried that if you do something make a drawing somewhere and you paste the URL, then I don't see it. So they filter it out. You can't paste URLs. Maybe if you obfuscate it a bit. I meant plot P2 at a capital P. Hopefully the AI understands that. What the... Why does it need a style for every bloody point? Got different color only. I think I'm pretty... It's pretty easy to keep the points apart, since one lives on a small circle, and the other one on a large circle. Initial direction. Yeah, I would also use right, to be honest. Twice circle radius, okay. Make a Q3. Circle radius 3. Okay. Centered coordinate system, add a point. Add the point Q3. We now also update Q3 when this is moved. Registered D3. Was the D3 defined somewhere? Oh yeah, yeah. Draw the circle. Close enough. Oops, what was that? This is our direction. Oh fuck, no, you don't, you have to be kidding me. It's doing it again. Oh shit. It even broke my, it even broke this one. What? It broke my code. I didn't see it in a div though. I want there to be also Oh, sorry, I have OBS open, which covers Discord. Okay, I see you now. Let's enter some picture here. Let's maximize that window. Okay, keep thinking. I need to go Ito at some point. So I hope you won't be mad if I suddenly leave in the middle of our conversation. Because the idea is, of course, that you continue it in another time, or on Discord. You can, anything you say or do on Discord, I will always read, even if the stream has stopped. But it might be a little bit later. Yeah, we can definitely do this on Discord instead of here. I think I have to pass through all 4 points. Yeah, sure, absolutely. You just don't know on which edge they are. So I think you have to categorize it and use a different algorithm for when the points are hitting different edges, different set of edges. Oh, yeah, no. How the hell did it get broken? I don't understand. The style, that doesn't break it. Initialization of a new variable, D3, does not break it. Initialization of a new variable, circle radius 3, does not break it. The declaration of a new point, Q3, does not break it. Centered coordinate system, add point, just a new point, does not break it. Restriction. Instead of plot Q to move to restricted, it's doing it again. This is bullshit. It changed this working line into something that doesn't work. And it even has the guts to what is the word, to, I don't think ChatGPT has guts, unfortunately, but it adds this comment to keep the direction D3 invariant. In fact, it's just, they're moving all over the place. Okay, so this is super wrong. Let's change that back to plot 2. This is center. Plot P2. Okay. Yeah, these might well be independent. I'll rotate this. Do I want to have that one move along? No, I guess not. Well, it doesn't really matter, I suppose. You first have to pick, you set this point and then set this one. And then change that one. I like the purple color here better. I think I'm going to get rid of that style. Just use the same style for the other point, for the new point. So we have a Q3 style. Let's just call this, I don't know, let's call it Q2 style anyway. This color is well better visible. Now these have the same color. I have new images from Mr. Cotarino. I'm afraid I see like 3 times the same image, 4 times, 5 times, 6 times. I see 6 times the same image. Hint, you can delete 5 of them. I can already guess what how the other images look like. Rotated. Not just... actually, we are probably right. Let's say no, it's again the same image. No, wait a minute. It's not the same image. You minimize it. That's not going through all 4 points. And again, not through all 4 points. And 3 times the same image. Oh, bad, bad, bad. Did you quickly write a Discord bot that automatically pastes URLs? No, yeah, we need a line. This is the direction. And then we need a line that is perpendicular to it, that goes through this point. Why not this point? Because then that one is not on the correct side. What about that one or this one? That is not correct, because then the intersection point, the vector to the intersection point, has a negative value for the dot product with the direction vector. In fact, we are looking for a given direction, we look for... You can draw a line through each of the 4 points, perpendicular to this direction vector. Calculate the intersection point with the line through that thing. And then calculate the dot product with between this one and from here to the intersection point, and then pick the largest one. That would give us this. That would give me this line here. Well, if this is AI generated, then it's a slop, because that the rectangle is not even going through all 4 points. But that's why it says bad, I guess. I'm gonna implement what I just said, but I also should eat. What shall I do first? Run over all 4 points. Let's dictate the stupid AI that I have here, which is no doubt going to fuck up again. Git commit A minus M wip. Het is goed met je. Well, you screw that up. The directions were all but invariant, but I fixed it. Next, draw a line. Draw one line. To find which line, run over all 4 intersection points. And generate a line. Tell it in what type to use. Of CSIT P2 frame. I'm an idiot. Point. The math goes here. And the bounding box doesn't go through all the 4 given points, is marked as bad. This picture is intended only for visualizing the problem. Yeah. I'm going straight for a solution. That is perpendicular to D3. well, whatever. Let's see what it does. Oh, no, sure. 4 points always, but not on different edges, on 4 different edges. I think you have to think about it as follows. Coterino. Take a piece of wood and then hit nails in it at the 4 intersection points that we have. Then take a long ruler, put the ruler against the nails, then it will hit 2 nails if you press it against it. And now rotate it. So if you rotate it one way, it will come free from one of those nails and rotate over the other nail. Or if you rotate it the other way, it comes free from that nail and rotate around the second nail. Yes, and if you keep rotating, it will hit another nail again, and then start pivoting around that one, and so on. And that would be one side. Then at every moment you can have another ruler which is on the opposite side of all the nails, but parallel to the current ruler that you have, and shift that towards that ruler until it also hits a nail. That would be the opposite side. And then you take 2 rulers perpendicular to both of those, left and right, and also move them towards the nails until they hit. And that is the rectangle, and that gives you all the rectangles, all the minimum rectangles anyway. Wait a minute, I'm wrong, am I not? Yeah, for example, your second image from the bottom, which it says bad, if the first ruler that I was talking about is the bottom there, and then yeah, you would generate exactly what you draw. That is not good. So what I described is maybe what you're doing. But that's indeed not always giving a solution. Why not? Yeah, okay. So I was wrong in saying that would be give it all. That also generates solutions where not all nails are hit. So then, as a second, as a final step, you indeed have to check that all 4 nails are touched by at least one ruler. And if not, reject it. Yeah, I think I understand your images better now. I thought it was a bit random, but this is indeed the way I would approach it as well, and then that's not sufficient to find. Yeah, you're totally right. Finally, I get it. You're smarter than me, I think. Yeah. Yeah, this is pure orientation, which is of course what I was doing as well in my description with the nails and stuff. So not every orientation has a solution. Yeah, okay, I get what you mean. I wonder if there's a way to speed it up a little bit, like something you can do to predict. that there will only be a solution if you have the ruler touching two nails, one side, because they just have to be touched, because like everything is bad in your case, except when you touch the two opposite sides, like the first and the second image, or touch the bottom side. Maybe there's a way to... I mean, the fact that those two are parallel gives you an infinite number of rectangles where they both are touched, obviously. And then the other one is, yeah, special in some way, that it gives a solution. So no solution for the case. Yeah, there's actually also a solution. Can you generate the image for... Oh yeah, well, I already see what the solution would be, but I think you're missing an image where you have the one side clamped against each pair. So if you go around then two neighboring corners, or just every edge of the polygon that you draw, the blue polygon, should be at some point aligned with the edge of your brown rectangle. And you only have the one at the bottom touching at some point, and then the other bottom at the opposite side of that. But not the northeast blue edge. That is never fully touched by the brown rectangle. Which well, it's almost equal to the fourth image. So it's also bad, but it's pretty much a special case that should be tested, I suppose. I can. Do we have any spectators to begin with? Well, we have 4 people. Okay, I think I can show them like this without even revealing too much. Oh well, no, we revealed everything. Streamer mode enabled. No, this is not working for me. But it's now too late, of course. Damn it. I'll do one image at a time. It would be go to the next image would be nice. So because the two blue edges here are parallel, this is a solution where you have 2 free sides. You don't know where those are. But if you're talking about the minimum, that well, this is not the minimum, so I would have drawn them as smaller. And then oh, you did that here, yeah. So here they are. This is actually the minimum then. And if you pick an arbitrary orientation, then there is just 1 or 2 points that you don't hit. Like in this case, there are 2 points that you don't hit with this orientation. And that is, well, here's one with just 1 point. 1 point that is not hit for this orientation. Orientation meaning the angle that the brown edges make relative to the whole universe here. And then here's another solution. And yeah, this solution is special in that if you rotate it a little bit clockwise or counterclockwise, then it's immediately not a solution anymore. So it's an island, an isolated case in the universe of rotations of the orientation. While I think it is also possible to have a continuous amount of solutions with a different shape. Probably not with this shape, the blue polygon, I mean. Yeah, I'll repeat for you the algorithm, but then I'll go eat, okay? So you can work on it, and then I'll address it later, or read the Discord again later. So the idea is that for every rotation, you can find a minimum rectangle if you reject the bad ones. But in some cases, you can enlarge the rectangle, like simply because that edge isn't hitting a nail or a corner. Like for example, in this case, oh no, that's a bad one. I need a. That's almost all four. No, not really all four actually. This one. So in this case, you could shift this side here to the left, because this point will stay on this edge anyway. So this rectangle that is larger still goes through all four. Yeah. So if you make the aspect ratio of this thing, if the I think the aspect ratio is already 2:1. But say it would not be 2:1, or you make the limit 3, then you can make this one bigger. You cannot shift it to the other side, because then you let go of this point. But this one is free. And of course, in this case, I guess the first case, well, probably this one's the best. So if you have just two edges, and each of those two edges have 2 points, then you have even 2 edges that are free. So these can be shifted. And then you restrict yourself to an aspect ratio of 2. So like I said before, if you shift this edge all the way here, then that one can be shifted to a certain point where then the aspect ratio is twice as long as high. And then the same shape can be shifted the other way, so you get a limit here. And you take both limits, so let's say the edge here and edge there, and then you get something with an aspect ratio that is even larger than 2:1. But that's just, for the bounding box important. So we take all non-bad solutions where the free thing is shifted as far as you can, as is allowed with the 2:1 ratio. And then the question is, the required output is a rectangle that is axis aligned with the original axis. So that what is the word? Includes, that is the smallest bounding box for all possible solutions. So in this case, let's say if this rectangle was the only one, then you would get a rectangle that hits this point, and hits this point, and hits this point, and hits this point. Axis aligned with the axis. So this is then the final output. But then you need the one that hits, that includes everything. It doesn't really need to hit it. But every solution, that would not be possible. as long as all brown solutions fall inside of it. And then of course you want to minimize that bounding box. Okay. Zero, 1 or 2 freedom of degrees, depending on how many edges are hit for that particular solution. Some solution might hit all 4 and there's no degrees of freedom. And some hit only 2 edges, which are 2 opposite edges. But that can only be the case if the original is parallel to begin with. Like in your case, which is a very special case, I think. Yeah, for example... no, what the fuck? That would not be the case here. If you use these points, then this line is not parallel to that line. And this line is not parallel to that line. So it's not possible to have 2 degrees of freedom. It is probably possible to have 1 degree of freedom. And if you consider this solution, then there is 0 degrees of freedom. But I think you can rotate this one continuously, I mean. So if you rotate the black rectangle a little bit, it still fits. It just keeps hitting all 4. It's I don't think it's an easy thing. That's definitely not an easy thing. Right. Yeah, the AI did generate something. I'm just gonna build it and run it, see what happens. I seriously go eat, damn it. Hup. So this was the idea indeed. To the line through this point, maybe we should draw that line as well, is perpendicular to this line, and this line goes through this intersection point. Let's put the intersection point somewhere else, like this. So this is say the 4 nails that we have, and this is a ruler that is pressed against it, and we just rotate around one of the nails, and then if we continue rotating, at some point it hits another nail, that one, and then it starts rotating around that nail, and then hits that one, rotates around that nail, and then it hits this one, and then it starts rotating around that nail, and so on. It's very blinky, but correct. Boing, 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 boing. And now, exactly at the moment that you had 2, those are special cases. You have to do maybe a little bit different. And at the moment you hit only 1, it's another branch of the algorithm. And then let's say we hit only 1, then I would you would have a ruler that is perpendicular to this one, that is moved in until it hits that one, and then you can already notice that this one is just not used. So maybe it's more like if you make a coordinate system out of this blue line, and this you make this the origin, then the fact that this thing has a larger coordinate than that one, while the anti-clockwise orientation is going from here to there, it's kind of required that this one also has the largest x value along the blue line. Otherwise, yeah, you just jump to the opposite side and then you want to jump back, but that's not possible. So if you rotate this thing so that along the blue line this one has a larger value than that one, then it becomes possible again. So just rotate it. That would be the case now. Yeah, so now it's almost the same, but this one is a little bit larger than that one. If you project this one, it goes like that, I think. So now you would hit a blue line perpendicular to this one would hit this one first. So you go like this, and then you go up here 90 degrees up, hit that one till here, and then you go 90 degrees that way, of course, parallel to this one, and then you go 90 degrees down through this one, and then it's still bad because you do not end up here. If you end up here, it's not good. To rotate it a little bit further. Now it would be a solution. So like this would be a solution. I think that's the way to find it. So yeah, we have now one line, but the other lines you can just generate immediately. And then either reject or not. Good. I'm going to eat, so I'll stop the stream anyway.